Now students, we come to the characteristics of chemical equilibrium. The first characteristics, that's chemical equilibrium is dynamic in nature. Dynamic in nature means, what is that? I am just going to discuss. You just say that the graph here is given, the graph that reaction rate of reaction versus the time. In this graph, you just see at the time 0, the backward reaction is almost 0, but forward reaction goes on, and as the time goes on, the forward reaction becomes very slow, and the backward reaction grow on increase, and at the time achieve that the both backward and forward reaction become same. That means the equilibrium attained. When the equilibrium attained, the concentration of the forward reactants and the concentration of the product both remain same during the equilibrium. But what that means? The reaction stopped? Not. The reaction is going on. At the same rate, the product is formed, and the product just produce the reactant in the same rate. So their concentration remain constant, but the internal reaction is going on. As the internal reaction is going on with the same rate, so the nature is dynamic. The chemical equilibrium nature is dynamic. Second characteristic is the properties of the system become constant at equilibrium. Properties of the system means the concentration and the other properties at equilibrium. When they attain the equilibrium, all these properties become constant. No concentration is changed and nothing as properties they are changed. Equilibrium, all the properties become constant until and unless we do not disturb the equilibrium. Now the third characteristic is equilibrium can be attained only if the system is closed. I am giving you an example of one of it, that calcium carbonate. I am heating the calcium carbonate. It will produce calcium oxide and carbon dioxide. I do it in two systems. Still, I have not gone through the thermodynamics, so the closed system, open system, isolated system, I can't say. But I am just giving you the just open thinking that if the calcium carbonate is heated in an open container, what will happen? The calcium oxide will produce and carbon dioxide will escape to the atmosphere. So calcium oxide is not available for the reversible backward reaction. For the backward reaction, carbon dioxide will not available if we done it at open. But if we do it in closed, carbon dioxide still present in the medium, and as both the backward process reactants, this is the backward process reactants present, they will do the reversible reaction to form calcium carbonate again, and at certain time calcium carbonate decomposition will attain equilibrium. But if we do it open, hold the calcium carbonate converted to calcium oxide, because carbon dioxide escaped out from the reaction medium. So the reaction medium should contain both the reactant and product intact. So it should be in a closed system. Clear?